The second part of this, they're going to give you some information, and they want you to try to draw a graph whose limits meet these conditions. So, for example, I'm going to tell you this particular one, we need to sketch a graph that has a domain from -5 to infinity. What does that mean if the domain is from -5 to infinity? What is domain? We just did a bunch of it. The domain is the set of what? When you all found a domain, if I said find the domain of, we just did these, if I said find me the domain of the square root of x minus 4, yeah, you all would have tested points and said, oh, it's positive on the right, negative on the left. So the domain is 4 and up. You did that just fine on your test. Okay, what's that mean in terms of a graph? That's the x values that are legal for that particular function. That's where that function is defined at. So if you were graphing it, this graph would only graph from 4 on to the right. You could only have x coordinates going from 4 to the right. So if I'm telling you this one has a domain of -5 to infinity, that means this graph goes where? X coordinates are starting at -5 and going to the right. So we can't have anything to the left of -5. So we're starting at -5 going right. Okay. Then I'm also going to tell you that f of -2 has to be undefined. F of 3 is supposed to equal 1. And then I'm going to tell you some limits. The limit from the left of -2 goes to positive infinity. The limit from both sides has to be a DNE, does not exist. And then the limit from the right-hand side of 3, limit from both sides of 3 is got to go to -1. Realize there are lots of possible graphs here. There's not one right answer. The answers that were given to you, that either I gave you or the back of the book gives you, that is one possible graph that's right. There's no set perfect graph here. There's lots of things that could make this true. Okay. What would you suggest we should put on there first? Is there any exact points we can plot? Yeah, f of 3 equals 1, so that means I have what coordinate? Well, yeah, 3 over 1 up. Because when x is 3, y is 1. So I know for sure that's a point that has to be on this graph. Now, a -2, it has to be undefined. What does that mean? It's either an open circle or it could be an asymptote. It's going to be an open circle or an asymptote. So the limits are probably going to have to tell us that one. Okay, with negative, how we do -5 could be several ways. Could it be an asymptote if it's got a bracket on it? No, can't. -5, we know that graph's going to start at -5, but since it's got a bracket on it, -5 has to be in it, so it couldn't be an asymptote. It's got to have a point there. So we'll probably just have some point there, and we'll get to pick. Okay, limits. If a -2 from the left has to go to positive infinity, if you're going to infinity, what does it mean you have to have? If you're going up to infinity, you have to have an asymptote. So we know -2 has to have an asymptote on it. For sure. Which side is going up the asymptote? Do I know that both sides of that asymptote going toward positive infinity, or just one side? The left side, this is -2 from the left, so we know the left side is going up the asymptote. The right side could be doing who knows what. They didn't dictate to us, so we'll actually get to pick here in a minute. Because they said the limit from both sides is a DNE, The other side can't go up the asymptote because they can't both be doing the same thing. The other side, the right-hand side, can go anywhere we want. It just can't go up the asymptote. We can go down the asymptote, we can put a point there, lots of choices. But it can't go up the asymptote. And then we know the limit as we approach positive 3, both sides, there's no plus or minus here, has to go toward negative 1. Okay, Matt says we're going to have a circle at 3, negative 1, because it's got, the limit has to be coming toward this point, but we already know we have that point above it. So, yes, the limit has to come in somehow. We can, whatever way you want to curve it, that's the beauty of this. You can take it any way you like. But we have to have, both sides have to come toward negative 1, that point sitting out of the way. And now, from the rest of it, it's kind of your pick. Where do you want to take things? This doesn't have to go up. Okay, Bailey wants a point at negative 5. Is that a preference where you want that point? Okay, you just made a point right on the axis. That works. Could be anywhere. We know it has, since it was a bracket domain here, we know it has to include it. And then where do you want to go from that point? Okay, yes. She just, we know we have to go up the asymptote, so she just took hers right up the asymptote, and that works fine. That'll work. Now, we know we have to connect in here to this open circle. We can come from anywhere on the right-hand side of this asymptote. It's totally your pick. So preferences. We can start from a point here and go, or we can go, it could have actually been following the asymptote. Totally up to you all. Doesn't matter. Asymptote? Okay. Naomi picks up the asymptote, so actually it would have actually been going down that asymptote. So that'll work. Because that keeps our limit at negative 2, it still does not exist. That works. And then finally, this thing has to go clear to infinity. So after we leave 3 here, we've got to keep going to the right somehow. How you all want to go? You can do insane. You can just shoot it off. You can sit and go, woo! You know, whatever you want to do. Just got to go from that point. As long as it's a function, which means it has to what? They always have to pass the vertical line test. Whatever you draw has to pass the vertical line test. That's really crucial. Beyond that, it's all up to you, your creativity in this. So sometimes people get bugged by these few problems because they left it so open. It's like, well, where should I put it? A lot of it's wherever you want to put it. You just have to meet these specific guidelines, and the rest of it you can do however you like. Yes. Okay, because the limit from both sides had to go to negative 1, we could never connect to that point. Because if you did connect, you'll not pass the vertical line test. And we know we had to connect down here. Now, they might give you some that would say the limit from the left goes to negative 1, and they might have said the limit from the right goes to positive 1, in which case you would add a piece connecting to the open circle, and then you add a piece on the right connecting to the closed circle. It depends on what they tell you the limit's doing. And if you can't tell, this is awesome critical thinking skills. Make you think about what this means. The key to calculus, I'll tell you right now, the key to calculus is processing the why you're doing what you're doing. You cannot just memorize and regurgitate steps to do algebra. You have to process why you do what you do, or it will cause trouble on down the road. So that was actually the tricky part. Now we're just going to do it with equations, old normal stuff. So now we get to just, this is more algebraic, so you'll probably be more comfortable with it. And we'll see who remembers our 1 day of limits from last spring. Does anybody remember how you do a limit? If I give you, this time I actually give you the expression in that limit. It's x squared plus 2. Can you remember the first step in the limit? Dump 1 in! Yes. All you have to do is sub 1 in. So if I do 1 squared plus 2, I'll get 3. Okay, if you get a legitimate number answer, ta-da, you're done with your limit. It's that simple. Okay. But do they always come out with just a nice number? And let me prove to you why that one's true. If we graph that one, what shape is x squared plus 2? Parabola shifted up 2. It's a parabola shifted up 2. So if I'm sitting here right here with a parabola, I ask you the limit as we approach 1. Well, I know when I plot points on a parabola, it's 1 over 1 up. So wouldn't that be 3? It jives. So if you drew the graph of these, it'll jive perfectly when you're doing it as an expression. But yes, first step of doing a limit is just sub the number in. Okay, but what if I give you something like this with a little more pizzazz and excitement in it? Still, you're approaching a number, so what's the first step? You should put the number in. Okay, how's our mental arithmetic? Yeah. 12 minus 8 minus 4 would indeed be 0 over 0. Is that an acceptable answer? Anybody remember the actual name of that? That is not considered undefined. Undefined is a number over 0. If the fancy word starts with an IN, it is considered an indeterminate form. You can't determine what it is. You cannot tell when you have 0 over 0. You're not sure what the value is. It does not mean it's going to be undefined. It does not mean it does not exist. You don't know for sure what it means. So you have to try some algebraic magic on it. What kind of algebra would be about the only thing we could try on this that we've done many times? Factor. It's a quadratic. It's a screaming factor baby. So I gotta factor it. What factors would you like? 3x and x, it's pretty much gotta be. Okay, 2 and 2, 4 and 1. Here votes for 2. That's going to give me 6x and 2x. Okay, I'm here. Negative on the right, so positive on the left. That'll give us a negative 6 and a positive 2, which makes negative 4 in the middle. And big hint, if you think this is going to factor and then see, it cancels. So a lot of times, guys, if you're debating your factors, check and one of your factors may well be what would cancel. So you should want to look for that. And that, since that cancels, that's now going to take out my indeterminate problem. Once it cancels, I can then do what with the 2? Now you sub it in again, and if you sub 2 in again, now you'll get what? 8. And so it actually turns out our limit was 8. So the y-coordinate of this graph is approaching 8 as our x-coordinate goes toward 2. We already know what happens when you have terms that cancel in a graph. You just did it. It's got a hole. That one will have a hole too. We already know that. It had a hole too, but there's still going, the limits coming to it are still going toward 8. So it's going to have a value. Okay, so we're going to make a big table or chart here of how to do limits. And over the next several days, we are going to add to our little limit tree. So the first branch is when x is approaching a number. What is the first step one should do when x approaches a number? Yes. You sub the number in. Okay. If you get an actual number answer, you're done. Okay. Right now, there's eventually going to be 2 branches here. If you get 0 over 0, you should try what? You should try factoring, or then there's going to be one other thing you can try on that branch. We're also going, the other side of the branches is going to be what happens when you get a number over 0. What do you do? And we're going to get through those branches today. Then we'll add more branches in the next upcoming days. So, that factors. Okay, are you comfortable with factoring? You want me to do another one you need to factor? We're good? Okay. Okay. You're remembering the other kind, and that's the other kind I want to do. Bailey said, what if we have square root things? Oh, thank you.